Hello class, I'm here to talk about chapter 7. Chapter 7 is talking about the central limit theorem, which I'm going to be calling CLT. Um, right here, your book does tell you that the CLT is one of the most powerful and useful ideas in office statistics. So the best thing you can do, I have added a video about bunions and dragons. So if you have not seen that video, please go ahead and check. That's going to be the most creative and easiest way for you to understand this theorem that is basically saying that the larger your sample size, the more it approaches a normal distribution. I am not going to be covering the right here the proportions, COT for proportions, the finite populations. I'm just going to be giving you the CLT for simple means and how to use it. So the best way for us to do that is first of all take a look at the videos and then take a look quickly at the chapter, which is a short chapter. The most important thing is going to be for you to look at the formulas right here. Every chapter give you a review. We are going to be using these formulas, not this right here, but everything else. So the way I did it is to put the problems in Excel. Before I can even go any further, um, I had found a website that would tell you there are several websites that you can practice the central uh, the COT. I don't know which one, not sure. Let me try this one right here. Okay, this is a good one. So we're talking that the COT, the larger the sample, the more it's going to represent a normal distribution. So for example, here, if I click on 2, you can see that it's very spread, the information, okay? But the more I collect, the more it's going to approach the middle right here. So let's go to 25. Let's see how it narrows all the values to fall over here. Actually, I had a picture. Let me see if I can, was it Blakesley? I have a picture over here that also it's going to make more sense for you. Oh, this one over here. So in this picture over here is talking about the difference in heights in the same population. So when they start, they just pick like a few samples, few people, and then one falls here, one falls here, one falls there. And the more that they increase the sample size or the number of people, they could notice that really the average it was right here, 5.8. See over here? And then everything else would fall about one standard deviation from the mean over here. And then we'll have a few what we call the outliers. We'll have one that is 410, and then we have one that is 6.2, and we have a few 6.1. So those are the ones that have a higher deviation from what we expect from the mean. So this is basically what the CLT in summary tells you. The larger your sample size, the more it's going to approach or the information is going to fall in the middle, in the center. Okay, so let's go back here to Excel. I have just assigned a few problems. Uh, I do understand there are 3 chapters this week, so this here should take you just a few minutes, no more than 5 minutes to answer. And then we're going to solve a problem, and that's going to be it for chapter 7. So let's start with the problem. Is right here says that the standard deviation of this distribution, the simple means, is calculated by sigma, which is the uh, population standard deviation divided by the square root of the sample size. This is what it means over here, which I have put in here for each problem so we can refer to it. Okay, so and also it tells you that the expected value of the mean on the population is equal to the mean. So the expected value of mean, or the sample mean, is equal to the mean. So if you have a question right here, what is ask you what is the expected value, it's going to be the same size of your mean. That's why I put it here as well. Let's just go ahead and quickly solve this. So you're going to see a population has a mean of 48. So my mu, which is this right here, or the mean of the population is 48. My standard deviation of my population is 5. And if we sample repeatedly with sample size of 36, 36 then is my sample size. And so what is the mean and the standard deviation? So right here it tells you the standard deviation uh, of the simple mean. So all you're going to need here is to do equals to sigma. I'm going through this. Sigma divided by the square root of my sample size over here, which is going to be 5 divided by 6. Okay, so now a population has a mean of 120. Well, and also here says what is the mean? Well, it tells you right there the mean. So we don't need to put that here. So a population has a mean of 120, a standard deviation 2.4. Standard deviation of the population. Remember, if you're talking about the mean of the population is mu, if you're talking about the mean of the sample is x bar, x with a bar on top, and if you're talking about the standard deviation of population sigma, if you're talking about the standard deviation of the sample is s. If you talk about the the population size, it's capital N. If you're just talking about the sample size, that's small n. Okay, so again, right here, if it's repeatedly with sample size of 40, what is the mean? The mean is 120. What is my standard deviation? The sample mean. So sigma over here, divided by my square root of n, my square root of my sample size, which is 40 right here. And that's going to be 3 divided by 8. Now, now pay attention how it changes. A population has a mean of 17, has a standard deviation 0.2. It sample repeatedly with sample size of 16. Now, what is the expected value in standard deviation? Well, the expected value is equals to the mean, which is going to be just like up here. So my mean is 17. And then now to do this standard deviation, we go back here. It's going to be equals to sigma divided by the square root of n, 16, which is about 0. It's going to be like 0.05 or something like that. So that's why it's showing as 0. If I would change here the format, it would show you now the format on the cell. Trying to make a short video for this one. So right here, let's do a number. There we go. So now a population has a mean of 14, standard deviation of 5, and you repeat 60 times. And again, what is the expected value? Well, the expected value is equals to my mean. And what is my standard deviation? Equals to sigma divided by the square root of my sample size, which is going to be 2 divided by 3, or about 0.65.